Today we're going to go over 4.1, 4.2, and 4.3. So we're going to do 3 sections today, and we're kind of shifting gears. We're going to start working with polynomials. So to me, this is easier than what we have just done. So I hope you agree. So here, let's just kind of look at it here in the context of the homework. So what we're looking at here are polynomials. So the word polynomial, it just means like one of these, mathematical expressions that has a bunch of terms, and each term can have both like numbers and letters, and letters raised to powers. So that's what a polynomial looks like. So let me write down some vocabulary here. So here's some stuff you need to know. Let's see, I want to use this. Okay, so here's what we want to talk about. So let's see. All right, so the leading term. Okay, this is an important part. Leading term of a polynomial. Okay, now you might think the leading term is the term that's written first, and a lot of times it is the term written first, but that's not really what the definition is. The definition is it's the term that has the highest exponent. Okay, so sometimes they'll be written out of order, and the leading term will actually be somewhere in the middle. They try to trick you by doing that. Okay, so but the leading term, you're always going to look for the term that has the highest exponent, like on the variable, basically. Okay, variable or variables. So sometimes there will be multiple variables. So you're looking for the highest exponent on a variable. That's the leading term. Okay, the leading term. So then the leading coefficient. Okay, so remember the coefficient when you have something that's like 3x, right? The coefficient is the 3. So the leading coefficient is just the coefficient of the leading term. Okay, so that's, once you've identified the leading term, the leading coefficient is just going to be the number, right? Like the 3 on that 3b to the 7th, or rather -3 in that case. Okay, so the coefficient of the leading term, and that last part's important. You need to include the sign, including the sign like in front, you know what I'm saying? Okay, so the leading coefficient is going to be that number with whatever sign is in front of that number. All right, and then a constant term. So a constant term is the last thing we want to talk about. A constant term is just going to be a term that has no variables. Okay, so like in the case we're about to do, this -5 here on the end, it's a constant term because, it doesn't matter what b is, this term is always -5. So the other terms would change, right? They're variable terms. If b is a different number, right? If b changes, these terms change, these first 4 terms. But -5 would never change because it doesn't have a variable. So that's why we call those terms constant terms. Okay, so with these definitions, this is really all we need. So that's why I'm saying, this is kind of a nice, it's not too bad today. So especially this section, this first section. Okay, so let's look at what it's asking us to do on these problems. Okay, so this one says, identify the terms, the degree of each term. Okay, so the degree, I guess I didn't write that, but the degree is the exponent of each term, right? So the degree of this term is just like 3, right? So that's the degree. And then the degree of the polynomial. Okay, so let me write those down. Sorry, so I got 2 more things I want to write down. So the degree of a term is just the exponent on that term. Okay, and then here's the other thing. If the term has 2 variables with exponents, you will add the exponents together. And we'll see an example to find the degree. Okay, so that's the degree of a term. Now the degree of the polynomial is going to be the degree of the leading term. So basically it's the degree of the term with the highest exponent. Okay, so remember the leading term is the term that has the highest exponent. So the degree of the polynomial is whatever that exponent is on the leading term. Okay, so now that kind of settles everything. Okay, so now we should be ready. Let me get back to the back. Okay, All right. Okay, so this one says identify the terms, the degree of each term, and the degree of the polynomial. Then identify the leading term, the leading coefficient, and the constant term. Okay, so what they want you to do in this first part, it's kind of confusing to know what they're asking. They want you to list all the terms of this polynomial, and they want you to separate the answers with commas. So you're gonna have to put it in correctly, right? So basically what they're saying is all the terms, right? So here are what all the terms are. Okay, the first term is negative 3b to the 7th. Okay, so that's the first term, and then they want you to say comma. Now the next term is negative 8b to the 4th. Right, they're just asking you to list all these terms with commas in between. The third is 4b to the 3rd. And the fourth term is 4b. Okay, and then that last term is negative 5. Okay, so it's important that you notice how I've got the negative sign in front. Like if there's a minus sign in front of a term, you've got to put that negative sign in front when you list it. Okay, and that's all it wants you to do on that first box there. Okay, so now it's going to have us list the degree of each term. Okay, so the degree of the first term, right? Not necessarily the leading term, although in this case it is, but this first term here, the degree of that term is 7. So I'm just looking at the exponent, right? And I'm saying the exponent is 7. The degree of the second term, okay? So that's going to be the 4 on 8b to the 4th. Okay, the degree of the third term is going to be that 3 on 4b to the 3rd, right? So I'm just looking at the exponent. The degree of the fourth term. Okay, so now if you don't see an exponent, right, you see there's a variable, right? The variable b is present there, but there's no exponent on it. Okay, in that case, we're going to say the degree is 1. So you can kind of put a 1 above the b in the exponent spot. Okay, and the reason you can do that is because b to the first power is just b. So when we have a first power, we just don't write it. Okay, but that degree there will be a 1. Now the degree of the fifth term, okay, if you don't have a variable, remember we call that a constant term, right? So if you have a constant term, the degree is going to be 0. Okay, so we call that 0 degree. That's just kind of by definition, that's just what we say. Okay, so all I did really was list out the exponents. Okay, now the degree of the polynomial, okay, so now we need to go over here. We need to figure out what's the leading term, right? What term has the highest exponent? And then the degree of the polynomial is going to be that exponent. What is that highest power, right? The power of the leading term. Okay, so in this case, the leading term is the first term. It's not always going to be that way, but in this case it is, right? So what did I do there? So the degree of the polynomial is 7, because 7 is the exponent, is the highest exponent we have, right? So it's the exponent on the leading term. Okay, and then the leading term of the polynomial. So now it wants us to go back up here, right, to where we listed out all the terms. Which term is the leading term? It's this negative 3b to the 7th. So we just need to write negative 3b to the 7th. Okay, so that's it. So that's all they want us to do. Oh no, there's one more thing. The leading coefficient. Okay, yeah, there's a couple more things rather. The leading coefficient, so that's going to be the number on this leading term. Right? So the number on that leading term is negative 3, right? The variable is b to the 7th. The number in front there is negative 3. Okay, and then this is the last thing. The constant term of the polynomial, it's going to be that negative 5 on the end. So I'm going to say negative 5. Okay. All right, so we're going to do, a few more like that, basically. That's what most of this section is all about. Okay, so like on number 2, so I'll do another one. Are there any questions on what we just did there? Any of the jargon, the vocabulary?
No, I don't have any.
Okay, all right. So let's look at a few more examples. So, all right, list the terms. So again, here we're just going to list them out. We're going to put commas between them. So b to the 5th. We're going to say 2b to the 18th. Okay, we're going to say p to the 8th. times b to the fifth. Okay, so when the variables are written right next to each other, like p to the eighth, b to the fifth, that's multiplication. It's p to the eighth times b to the fifth. And then again, -5 is going to be the constant term. Okay, so there's the list of all the terms. Okay, so now the degree term by term. All right, so the first term is b to the fifth. Okay, the degree is 5, right? That's the exponent there. Okay, the degree of the second term, that's going to be 18, right? B to the 18th. All right, now here's where you can get kind of tripped up. The degree of the third term. Okay, so remember, with the degree, it's the exponent on the term, right? If the term has two variables with exponents, you need to add the exponents together to find the degree. Okay, so p to the eighth, b to the fifth, I need to add 8 and 5 together. Okay, so the degree of that term is going to be 13. Okay, and then the fourth term is the constant term, -5. So always we just say a constant term is degree 0. Okay, now the degree of the polynomial, so basically now we just go back and look at all 4 of these numbers. Which number is the highest? 18. Okay, so that means the degree of the polynomial is 18. It's the highest exponent in the polynomial, the highest degree of all the terms. Okay, now the leading term of the polynomial is the term that this exponent was on. So that would be 2b to the 18th. Okay, and then the leading coefficient, so the coefficient of this leading term is just a 2. And then the constant term is -5. Okay, let's see. So I'll do one more of these, and then I think eventually y'all should feel good about doing ones like this. So let me do one more. Okay, so I'm going to list out the terms. So 3w to the 8th. Okay, and then 9w to the 9th, d to the 4th be the next term. Whoops, that got messed up. D, there we go, d to the 4th. Okay, and then there's 5w to the 5th, d to the 5th. Then there would be 6w to the 5th. And then the constant term at the end is -4. Okay, and I'm looking, I think that's right. Okay. Okay, the degree of the first term, so that exponent is just an 8. Okay, the second term, we have to add the 9 and the 4, so we get 13. The third term, we would add the 5 and the 5, so we would get 10. The fourth term, we just have a w to the 5th, so that would just be 5. Okay, and then the fifth term is going to be the constant term, so the degree is 0, right, on a constant term always. Okay, so that's that part. Now the degree of the polynomial, okay, so now we look back at all the degrees, right? 8, 13, 10, 5, 0. So the highest degree is 13. So that's the degree of the polynomial. Okay, now the leading term is the term that had that degree. Okay, so remember that degree was on 9w to the 9th, d to the 4th. So we just write 9w to the 9th, d to the 4th. Okay. Now the coefficient on that term is the 9 that's out front. And then the constant term is going to be that -4 again. Okay, so that's that. All right, so now we are moving to a different type of question. So let me show you now. So descending order, descending powers. Okay, so this is another vocabulary thing. So let me write this down. Okay, so to arrange a polynomial in descending powers of some variable, right? In this case, it's c. So like, for example, c or x or whatever, right? Descending powers. So start with the term. Descending means you start with the term with the highest power. start with the term with the highest power of that variable. Oops, variable, and go in just basically descending order of powers. Okay, so that hopefully that makes sense, right? You're just going to start off with whatever the highest power of, you know, whatever variable. Okay, so in this case, arrange the terms of the polynomial in descending powers of c. Okay, the highest power is that negative 4c to the 7th. So you have to make sure you bring the sign with it, right? So negative 4c to the 7th. Okay, the second highest power would be minus 4c to the 5th. Okay, now the third highest power is just going to be plus 5c, right? Remember, that would be like a 1 on that exponent. And then the lowest power, there's no c on 28, so that's going to be the lowest power. Okay, so that's descending order. Okay, so now we're going to look at polynomial functions. So this one says evaluate the polynomial function for the given values of the variable. Okay, so this is just something we call function evaluation. Okay, and so this is going to be where your calculator will come in really handy. Okay, so let's see. So we have, this is number 5. Okay, so they give us a function, polynomial function p of x. Okay, and it's got this formula 3x squared minus 2x plus 5. Okay, and they're asking us to find 3 function values. So like p of 1. Okay, so remember, p of 1 means you put a 1 everywhere you see the x. Okay, so 3 times 1 squared minus 2 times 1 plus 5. Okay, and then we're just going to evaluate this. Now this one's really easy because, you know, anything times 1 is itself. So like 1 squared is 1, right? So this becomes just 3 times 1 minus 2 times 1 is 2 plus 5. So we end up, we find that this p of 1, 3 times 1 is 3. So it's 3 minus 2 plus 5. Okay, 3 minus 2 is 1. 1 plus 5 is 6. So p of 1 is equal to 6. So that's what you'll put right here. Okay, p of negative 2, right? So most of these we're going to be able to do without the calculator. If you want to use your calculator, I'll show you that in just a second. All right, p of negative 2, so you're going to go 3. So you're putting the negative 2 everywhere you see an x. So 3 times negative 2 squared minus 2 times negative 2, and then plus 5. Okay, so here's where you got to be careful, right? So you know when you square a negative number, it becomes positive. Okay, so that's something you're going to have to, you know, watch out for. Okay, so that means 3 times negative 2 squared. Negative 2 squared is 4, so this is going to be 3 times 4. Now here we have minus 2 times negative 2. So if you count the negatives, you have 2 negatives. That makes a positive 4. And then plus 5 at the end. Okay, so it looks like p of negative 2, okay, we're going to have 3 times 4 is 12, and then plus 4 plus 5. Okay, and so what do we end up getting? For p of negative 2, we've got 12 plus 4, that's 16, and then 16 plus 5 is going to be 21. Okay. All right, and let me see if my calculator is working. I think it is. Let's see, let me give it a second. I think it's going to warm up here. All right, I'll do p of 0 while we see. Okay, yeah, here it is. All right, so let me show you, like, let's say you're not feeling super confident about getting that p of negative 2. Okay, so if you want to do this in your calculator, you want to go to this line right here, right? Once you plug the negative 2 in for x, look at this line, right? You can just enter that line in the calculator, and it's going to give you the correct answer. So in other words, you go 3, and then open parentheses times negative 2 squared, then minus 2 times negative 2 plus 5. and then it gives you the answer 21. Okay, so if you want to use your calculator, it's just like that. Now, the nice thing about using the calculator, because next it's going to ask us to find P of 0. So, P of 0 is pretty easy. So like, normally you might not use the calculator in this one just because, everything's multiplied by 0. Well, when you multiply by 0, you just get 0. But let me show you what you can do with the calculator. So once you've entered it one time, right, we've entered this function. Let's say we want to do P of 0 now. We want to enter this line. So all we have to do, you can hit this second button here and then hit enter, and it brings up the previous line you typed in. So then all you have to do now is change each -2 to a 0. Okay, so this can come in handy when you have, something more difficult. You don't want to keep on typing in the same thing, right? And so this gives us the answer 5. So that means P of 0 is 5. Okay, so that's how you can use calculator.
Can you wait, is that the last one? Oh, I don't know. Can you scroll up in to where you had the notes for arranging a polynomial and descending something?
Descending order?
Yeah, I was just trying to write the rest of that down right quick.
Okay, so it's right. Can you see it now? To arrange a polynomial in descending powers of some variable, you're going to start with the term with the highest power of that variable and then just go in descending order of powers, right? So like, so just as the variables, like, notice this one we just did is in descending order. It starts with an x squared. This would be an x to the first, and then here's no x. So you just basically go from highest power to lowest power.
Okay.
All right, so let's see. So P of 0 we found is 5. Okay, so that's just function evaluation there. All right, collecting like terms. Okay, so that's number 6. So, when we collect like terms, okay, we're looking for the terms that have the same variable, right? The same variable to the same power. 6b squared minus 14b squared plus 17b squared. Okay, so a lot of y'all probably are going to find this familiar, but let me just write the rule here. Okay, so the rule is this. It's when terms have the same variable to the same power, right? Like what we have here with the b squared, you can add the coefficients. Say add or subtract, right? Because sometimes it's going to be subtraction. You can add or subtract the coefficients of those terms, combining terms to make a single term. Okay, so like in a problem like this one we're looking at here, we're going to end up with a single term. Okay, so let me show you what that looks like. All right, so we have 6b squared, right? These are all like terms because they all have a b squared. Okay, so if they all have the same variable to the same power, okay, like this, so what we're going to do is we're going to add or subtract the coefficients. So what we'll say is that this is equal to, this up here equals, okay, so we're going to add the coefficient. So what I'm going to do, I don't usually write it like this, but I'm going to write it as, it's like 6 minus 14 plus 17, right? Whatever that is times b squared. Okay, and so now if we just do 6 minus 14, we get -8, and then -8 plus 17 is 9. Okay, so that's just going to be 9b squared. Okay, so if you have like terms, you combine those coefficients, you add or subtract the coefficients, and then you end up with a single term, right? So you end up with just like 9b squared, like that. So that's what you'd say the answer is, 9b squared. Okay, so here we've got, in number 7, we've got some different terms, right? Or we've got different variables. Okay, so we've got 12v minus 4d minus 8v plus 48d. Okay, so the terms with the D's are like terms, and the terms with the V's are also like terms, right? So I'm going to underline the V's with a squiggly line, and then I'm going to do the D's like this, right? So those are the terms we're going to combine. Okay, so I'm going to use an extra step on this problem, and I'm going to write the like terms next to each other, right? So I'm going to write, this is 12V minus 8V, right? I'm putting those next to each other, and then I'm going to say minus 4D plus 48D. Okay, so I'm putting the terms with the same variables next to each other. Okay, and so now I can do what I did before. So again, these are sort of like extra steps because we're learning it. So now I'm going to do the 12 minus 8, right? So now I can say whatever 12 minus 8 is times V will be that term. And then this one will be plus, and here you would have to write negative 4 plus 48. Okay, whatever that is times D. Okay, so 12 minus 8 is 4. So I end up with 4V, and then minus 4 plus 48 is going to be plus 44D. Okay, and so now you can't combine these two together. So this is the answer, 4V plus 44D. Okay, so now we're introducing a third little wrinkle here, which is that constant terms are like terms. Okay, so, and this is very intuitive, right? You can combine terms that have the same variable. Well, what if they don't have a variable, right? Well, if they don't have a variable, you can combine those two, right? Because you can do 4 minus 2. That's what we're going to do in this problem. Okay, so we've got 11W plus 4 minus 2 plus 8W minus 12W plus 1. Okay, so let's write all the W terms together. Okay, so that's 11W plus 8W minus 12W. Okay, and then let's write all these constant terms together. So then plus 4 minus 2 plus 1. Okay, so once you get the hang of this, you might skip some of these steps, right? Like this next step where I'm going to write, okay, I'm going to combine all the coefficients, 11 plus 8 minus 12, whatever that is, times W. And then this one would just be 4 minus 2, that's 2. And then 2 plus 1 is 3. So I'm just going to add 3 on the end. Okay, and now this 11 plus 8, that would be 19, right? And then 19 minus 12 would be 7. So the answer is going to be 7W plus 3. Okay, so they just start, giving you weirder and weirder, like WG, right? If you have a WG and a WG, you can add those together, right? So, so like we got 8 W squared minus 5 WG plus 16 G squared plus 6 W squared minus 2 G squared. There's a lot of terms here. Plus 40 WG plus 10 G squared. Okay, so now we can use our one line to write the like terms next to each other, right? So we've got, let's see, we've got 8W squared and a 6W squared. Okay, so I'm going to write those next to each other. 8W squared plus 6W squared. Okay, so I did those two. Those two are gone. Now I'm going to do my WGs. Okay, so now I've got minus 5 WG plus 40 WG. So I'll combine those two. All right, so now I've taken care of these. So I'm going to underline them so that I know I've transferred them down to the second line here. Okay, now I'm going to do my G squared. So I got 16G squared minus 2G squared plus 10G squared. So I'm going to write all those. Plus 16g squared minus 2g squared plus 10g squared. Okay, and now this time I'm going to skip that step where I put the coefficients in parentheses, right? I'm going to see if I can just do this in my head, right? Because I know 8 plus 6 is 14, so that's going to be 14w squared. Okay, and then minus 5 plus 40 is plus 35. So that's plus 35wg. And then 16 minus 2 is 14, and 14 plus 10 is 24. So that's going to be plus 24g squared. Okay, and so once I get here, now I can't combine anything else. So now I'm done. So my answer here is, let me scoot this over so I can see, 14w squared plus 35wg plus 24g squared. Okay, so now we're going to look at how introducing parentheses affects these. Okay, so, you know, stop me if you had any questions over any of the like term stuff, right?
Okay, I'm gonna stop you, sorry.
Okay, go ahead.
My mic was muted, sorry. Okay, up there where we just were number 9, you have 8w2, you know, plus blah blah blah. Why didn't at the bottom, why didn't you put why didn't you do it as a -5 plus 40? Why is that just plus 35?
Well, it's like you're adding, so like if we do the step where we put them in parentheses, right?
Mm-hmm.
-5 plus 40 is positive 35. Like, so let me go back, let's see. Okay, let me put in a line that would go in between. Whoops. My email is sometimes pops open. Oh geez, what is going on here? All right, so if we look at, yeah, so let's look at this line we can put in here, right? The line that would go in between. So that's where we would put all the coefficients in parentheses, right? So we'd say it's 8 plus 6 w squared. Okay, now we're gonna say plus, right? And it's gonna be plus, minus 5 is like -5. So it's plus -5 plus 40 wg, right? And then the same thing over here with these 3g squared terms. It's gonna be plus, it'll be 16 minus 2 plus 10 g squared. So does that make sense? You know, because then when you do -5 plus 40, the answer is 35.
Oh, okay.
Right. So you just, it's just kind of the same rules as goes, like if I were to ask you what's -5 plus 40, right? It's those same rules that, you know, it becomes 35, right? So just the way that works, that means that -5, you know, let's say WG or just X, right? -5X plus 40X is equal to 35X. It's almost like the X's don't even matter. You just carry the variable along with you.
Okay.
Okay. Yeah, good question though. Okay, so, all right, everybody else good? Anybody else have a question on these? I think it's good if you have questions. That helps you kind of figure out what's going on. Okay, all right, so I'll continue on here. All right, so now what we're looking at, so this is a similar problem to what we've been doing, but the difference is these parentheses, right? So let's see what parentheses do for us. In some cases, they're not really going to change much, like this first problem. The parentheses we can just kind of get rid of. And the reason is that we're doing addition between the parentheses. Okay, so when we have just a plus here, the parentheses really aren't going to matter that much. Okay, and I'll show you what I mean. All right, so I've got 5c squared plus 9t squared plus 12, excuse me, plus 2c squared minus 3t squared minus 6. Okay, so like I said, when we have a plus between the parentheses, we can basically just get rid of the parentheses. They're not really going to do anything in this problem, okay, because you're just adding these two quantities together. So, so there's some rule of addition that says, okay, well, you can just change the order. You can do whatever you want. As long as it's all addition, you don't really have to worry about the parentheses. Okay, so that's what I'm going to do. I'm just going to lose the parentheses, and then I'm going to do it just like I did those last few problems. Okay, so now I've got one that looks just like what we've been doing. Okay, so I'm going to write the like terms next to each other. So the 5c squared and the 2c squared, I'm going to write back here. 2c squared. Okay, so I'm going to add those 5 and the 2 in the next line. Okay, now I've got 9t squared minus 3t squared. Okay, those are like terms, 9t squared minus 3t squared. And then I've got plus 6 minus 12. So I put that on the end. I'm sorry, what plus 12 minus 6? Said that wrong. Okay, and so now, yeah, all the terms, right? I've written all the terms down the line below. So now I'm just going to add the like terms. Okay, so 5 plus 2 is going to be 7c squared. Okay, and then 9 minus 3 is going to be 6, so plus 6t squared. And then 12 minus 6 is 6. Okay, and so that's going to be my answer. I can't simplify that anymore. So I go 7c squared plus 6t squared, and then plus 6. Okay, so now we're gonna talk about something next here that's called factoring out a negative. So this gives a lot of people a little bit of trouble, but you need to understand how factoring out a negative works to understand kind of like what a minus sign does. So factoring out a negative. Here's what we're gonna do. We factor a negative out of the expression, and then we change the sign on every term. Let's see. So we factor a negative out of the expression using parentheses. So we're going to put parentheses around the polynomial, and then we're going to change the sign on every term of the polynomial in our new parentheses. So we're going to introduce a parentheses. Okay, so let me show you. It's not supposed to work like that. Say, oh, maybe I can just go back. There we go. Okay. So now here's what we're going to do. So we're looking at number 11. Okay, they give us, it's 10a to the third. 10a to the third minus 5a squared plus 6a minus 7. Okay, and they say write two equivalent expressions for the opposite of the polynomial. Okay, so the first thing we're going to do here is we're just going to factor out a negative. Okay, so the opposite of the polynomial means factor out a negative. Okay. Okay, so we factor out a negative of the expression using parentheses. Okay, so here's what we do. To factor out a negative, you're just going to write equals. You're just going to introduce a negative on the outside, and then you're just going to put the polynomial inside the parentheses. Minus 5a squared plus 6a minus 7. Okay, and I wrote an equal sign. They're not exactly, it's not exactly equal, but yeah, I guess I shouldn't say that's equal. These two things are not really equal. This is the opposite. This one here on the bottom, this is the opposite of this one on the top. Okay, and by opposite, we mean just like 3 and -3 are opposites, right? this is the opposite of this in that same way. Okay. So now this is one expression for the opposite of this. Now the other expression, okay, so now this is equal. This, what I'm about to write, is going to be equal to this bottom part. I'm basically going to distribute the negative sign to every sign that's inside the parentheses. Okay, so if it's plus, I'm going to make it minus. And if it's minus, I'm going to make it plus. Okay, so the negative sign just goes to everything in the parentheses. So that looks like this. So it's negative 10a to the third. Okay, now minus negative 5a squared is plus, right? So I make all the minus signs plus. Now minus, this will be minus 6a because it's plus 6a. And then this is minus 7, so it'll be plus 7. Okay, so this expression here and this bottom expression here, they're both expressions that are the opposite of this thing we started with up here. Okay, so what it wants me to do here is it just wants me to write both of those bottom two ones with commas. So first I'm going to write negative 10a to the third minus 5a, 10a to the third minus 5a squared plus 6a minus 7, okay, and then end your parentheses. So that's the first one, comma, now I'm going to write the second one, negative 10a to the third plus 5a squared minus 6a plus 7. Okay, all right, is that one's a little strange, but is everybody feeling okay there?
Yeah, I understand it pretty well.
Okay, cool. All right. Okay, just, yeah, let me know if you got a question. I'll continue on. All right, so now we're going to basically use what we just learned to subtract polynomials. Okay, so notice how that negative sign distributed, right? That's what we need on this next problem. So number 12, we're going to subtract these two polynomials. So 2w minus 9 minus this next polynomial, negative 5w plus 8. Okay, what we're going to do with this negative sign right here between the two parentheses, we're going to distribute it just like we did on this previous problem. So in other words, we're going to distribute the negative here to the 5w, and we're going to distribute it to the plus 8. Okay, so we're going to do that, and then we're going to do our subtraction, or we're going to combine like terms, basically. Okay, so this first set, this first parentheses here, I can just lose the parentheses. I don't really have to do anything to them. I just get rid of the parentheses. Now the second set, okay, I've got minus negative 5w, so that's where I change that to a plus 5w. And then minus positive 8, I'm going to have minus 8. Okay, and now I can add these together. So now I can say, I'll write them together, 2w plus 5w, right? I'll add those. And then I'll also do minus 9 minus 8. Okay, so 2 plus 5 is going to give me 7w. Minus 9 minus 8 is going to give me minus 17. Okay, so that's my answer there. So 7w minus 17. Okay, so now we've got a bigger one here where we're subtracting. So we're doing the same thing here, but it's going to be, more complicated. Okay, so number 13. Okay, so we've got 4b squared minus 4b minus b to the third. Okay, and then minus, now we have another polynomial here, 8b squared minus b to the third minus 19b. Okay, so again, I'm going to distribute the negative there, right? So that means I'm going to distribute it to the 8b squared. I'm going to distribute it to the minus b to the third. And I'm going to distribute it to the 19b. So all three terms in parentheses, I need to change the sign on those. Okay, so just like in the last problem, this first term here, the parentheses don't really do anything. So I just get rid of the parentheses. So So 4b squared minus 4b minus b to the third. Okay, and now I distribute the negative. So minus 8b squared, right? Because 8b squared was positive here. Now minus b to the third is plus b to the third. And minus 19b is plus 19b. So you just change the sign of everything. Okay, so now I'm going to write my like terms next to each other. Okay, so my b squared terms, I've got 4b squared, and I've got minus 8b squared. So I'm going to write those next to each other. I've got minus 4b, and then I've got plus 19b. Okay, so let me mark the ones I've done. I've done that one and that one and that one and that one. So what's left is minus b to the third plus b to the third. Okay, so now I've done that one and that one. Okay, so now I've got all the terms taken care of. Okay, so now I can just say, okay, 4b squared minus 8b squared. All right, 4 minus 8 is negative 4. Okay, so that's negative 4b squared. Minus 4b plus 19b. Okay, well, minus 4 plus 19, that's positive 15. So positive 15b. These last two here, right, minus b to the third plus b to the third, these are going to cancel out. Okay, it's like minus 1 sort of in front, you know, it's like minus 1b to the third plus 1b to the third. So it's like minus 1 plus 1, so it just cancels out. Okay, so all I've got then left is going to be this. This is my answer, minus 4b squared plus 15b. Minus 4b squared plus 15b. Okay, so that's it for section 4.1. Okay, so how's everybody feeling? We doing okay?
Yeah.
Yeah.
Okay, no questions?
No, I don't have any.
Okay. Okay, so that took us about 45 minutes, I think. So let's go ahead and do, so I'm going to save this. Let's go ahead and move on to 4.2.